Okay, this is 8.06, which is part 2, where I'm actually going to be solving quadratic equations by completing the square. So anytime you see this word solve, your goal is to get x equals, right? Your goal is to solve for x. So everything that we do so that we can isolate x. The one thing that we need in order to do this, we need to remember that if we're solving for x here, right, we can square root both sides in order to cancel out the x squared. However, we actually know that there are two solutions to this, positive 5 and negative 5. So we have to add a plus or minus to the outside of the square root. So x will equal plus or minus 5. Same thing holds true here. This is a perfect square. It's something squared. So we can square root both sides, leaving us with x plus 6 equals plus or minus the square root of 64. We'll leave this as x plus 6 equals plus or minus 8 for now, but we will be actually isolating x. So let's go ahead and solve these two problems by completing the square. If we are completing the square, we need the two x variables on the left side by themselves. So I'll start by subtracting the constant. I'm left with x squared plus 8x equals 4 minus 16 is a negative 12. Now I'm actually going to complete the square by adding some value to both sides. That value is b divided by 2 squared. So b divided by 2 squared. Rewrite this as x squared plus 8x plus 8 divided by 2 is 4. 4 squared is 16. The purpose of that was so that this was a perfect square. This is x plus 4 times x plus 4. Negative 12 plus 16 is 4. So this is how far we went yesterday. Today we actually need to solve for x, so we're going to go ahead and square root both sides to get rid of the x squared. This is x plus 4 is equal to plus or minus the square root of 4. I'm going to simplify that in a little bit. I still need to isolate x, so I'm going to subtract 4 on both sides. This is x equals negative 4 plus or minus the square root of 4. So this is where we split this up into two equations. We have x equals a negative 4 plus the square root of 4, and we have x equals a negative 4 minus the square root of 4. Square root of 4 is 2, and x negative 4 plus 2 is negative 2. Negative 4 minus 2 is negative 6. So x equals negative 6, negative 2. For number 2, we're going to start by doing the same thing. If we are completing the square, then we need to isolate the two variable terms. So I'll add 4 to both sides. We're left with 2x squared plus 16x equals 18. Now, I actually need a to equal 1, so I'm going to divide every term by 2, so that a equals 1. Next, since I have a equal to 1 and there's no constants on this side, I need to add a value such that this becomes a perfect square. So I'm going to do that by doing b divided by 2 squared. X squared plus 8x plus 16 equals 9 plus 16. 9 plus 16 is 25. This is x plus 4, again, when you factor it. Going one step further, we need to solve for x, so we'll square root both sides, leaving us with x plus 4 equals plus or minus the square root of 25. I need to subtract 4 on both sides in order to isolate x. X equals a negative 4 plus or minus the square root of 25. Again, this is where you split the equation up into two equations. X equals negative 4 plus, I'll go ahead and simplify here. Square root of 25 is 5. and x equals negative 4 minus 5. So this is x equals 1 and x equals negative 9. So the next level of work for you is there going to be problems where they're not set equal to like perfect squares, like the square root of 25. So what you need to know how to do for those is you need to know how to reduce radicals. When reducing radicals, we need to first think about like the square root of 25. That is the square root of 5 times 5. And the reason the square root of 25 is 5 is because there's two numbers. There's one number times itself underneath the square root. So similar to how we reduce fractions, the first thing we're going to do is we're going to reduce square root of 18 by rewriting it as its factors. Square root of 18 is, say, 2 times 9. Reduce it again, that's 2 times 3 times 3. If there are two of the same number underneath the square root, we're going to remove one of them. Since the 2 is still under the square root, we'll leave it under the square root. Let's do the same thing for square root of 24. First, rewrite it as its factors, which are, say, like 6 and 4. Break that down. 6 is 2 times 3. 4 is 2 times 2. If there are two of the same number, you'll remove one of them. And then since there's just one of each of those, I'll multiply them back together to get the square root of 6. Now, doing this problem, why don't you just check the answer key to see how I reduce that radical.